Before we start doing our shell method, I want to make sure that y'all understand disk and washer method first, and if y'all don't, that's completely fine. I have a video on each in the description below, as well as a Calculus 2 playlist that I'm currently working on so you can follow along in your classes. So again, before we start the shell method, let's see the difference between using disk and washer and the shell method. So with disk and washer, I want you to remember that, and let's use y equals the square root of x as our graph bounded by x equals 1. Our rectangle that we draw is going to be perpendicular to our axis of rotation. So notice here that our rectangle is upward like this, and our axis of rotation, which is x, is going to be like this, which has a perpendicular cross section. Now, in contrast with our shell method, if we draw the same exact graph, our rectangle will be parallel to the axis of rotation, which is obviously the opposite of perpendicular. So the axis of rotation here is x, and our rectangle is going upwards like this, showing both of them are parallel. And an illustration of the shell for the shell method, if we just reflect it, will look a little something like this. And that is our shell. Now, the equation we use for the shell method is volume equals 2 pi times the integration from a to b of our radius times our height, and then dx. Now let's let our first problem be bounded by y equals the square root of x, y equals 0, x equals 2, as well as rotated about the y-axis. And then let's draw our graph as well with our x equals 2 bound. And then our y-axis symbol rotation, and then our axis of rotation, which is the y-axis, which, since it's the y-axis, let's let it be parallel to the long side of our rectangle. Now if we bring our formula over here, let's try to figure some things out. So far, we know our bound is from 0 to 2, so we can write that in. But what is our radius? Well, the first thing I want you to remember is that our radius is going to be the distance from our rectangle to the axis of rotation. Always remember that. And visually, this kind of doesn't really make sense, so I'll draw the opposite side. But notice here, when we draw the opposite side, we have our circle on top, and I'll put our radius in red. So that is going to be our r of x, which, if you notice, is equivalent to x, because look, it's going on the x side. That's our radius right here. This is the x-axis right here. So we can plug that into our formula as our r of x. And our height is obviously going to be in parallel to our y-axis. So our height equals y. Now, something that's kind of off here is that we are in terms of y, and we need to put it in terms of x since we are all putting our variables in x. So to do that, we know our y equals the square root of x. So let's plug that in. And now we have our h of x. If we just simplify this equation, we can look at it as x times x to the 1/2, because that's the same as the square root of x. So this is basically just 1 plus 1/2, which is the same as x to the 3/2. And now we just integrate. So then we get our volume equals 2 pi times 2x to the 5/2 over 5, bounded by 0 to 2. And when we plug in our 2, it ends up becoming 2 pi times 2 to the 5/2 over 5. And then our answer ends up becoming 16 pi times the square root of 2 over 5. I just wanted to do one more problem where our shell method is now bounded by two curves, and it's not too much different because our height is literally just right minus left or top minus bottom. So let's make our two equations, y equals the square root of x and y equals x squared, and rotate it about the y-axis. Now we graph these real quick, and this is our region we're finding, rotated about the y-axis. So you can see this rectangle is parallel to the y-axis like this. So we will use shell method by this given formula. And we also know that our radius is basically the distance from the rectangle to the axis of rotation, which we can see in this red arrow. And so we know that our r of x is the same as x. Now to find our height, we literally just do the top curve, which we can see over here is y equals the square root of x, minus the bottom curve, which we can see is y equals x squared. So let's do that. And then the integral from a to b, 2 pi dx. And now let's find our bounds. So all we do is set our y's equal. We see that if we square it, it becomes x to the 4th, which equals x. And then it becomes x to the 4th minus x, which equals 0. We then factor out 1x, get x times x cubed minus 1, and find out that our x's equal 0 and 1. So now we know our bounds. So we could just erase that over here and replace it. Now, one thing to note is if you can never tell between the top and the bottom or the right and left curve, you can always just plug in between a number from 0 to 1 or whatever your bounds are, which in this case is 0 to 1, into the equation. So for example, let's do 0.5 as our x. We know our equations are the square root of x and x squared, and you'll come to figure that this number is going to be bigger. So that will be the one that we will put first. And then we'll subtract the x squared. Now we can bring this little integral down here and solve for it. So we will simplify the integral, and x times the square root of x is the same as x times x to the 1/2. And then we will subtract it by x times x squared, which is the same as x to the 3. And we end up getting x 3 over 2 minus x cubed, bounded by 1 and 0 times 2 pi in the end. And then we can integrate. And with our integration, we end up getting 2 pi times 2x to the 5/2 over 5 minus x4 over 4, bounded by 1 to 0, or 0 to 1, sorry. And then we find out that our answer is just 2 pi, plug in the 1. And the reason I don't subtract the 0 is because we just know it's 0. So no need to do that. Ends up being 2 over 5 minus 1 over 4. We then find our least common denominator and end up getting 8 over 20 because we multiplied 4 over 4 as well as 5 over 5 minus 5 over 20, which then gets us 2 pi times 3 over 20, which then gets us 6 pi over 20, which then simplifies to 3 over 10 times pi. And we are done.